Okay, ladies and gentlemen, this is probably about the fifth or sixth time I've tried to create this video. The first few times didn't have any sound, so hopefully if you'll bear with me, I'm going to try to get through this worksheet. On the first few events, on number one, it says that they're mutually exclusive. Remember, that means they have nothing in common. So as opposed to this next one where they are mutually exclusive, it says the probability of A or B. All right, in the first one, you just got to do probability of A plus probability of B. What they're saying is if I add up all of A, if you notice, I'm going to highlight this right here. That's all of this. And if I do probability of B, that's all of this. Well, notice they have an intersection right here that I have highlighted twice, this part right here. Well, in that case, let me make it a little different color. Let's do right here, white. All right. Because of that, you have to subtract it because you can't count it twice. So what I want to do is I want to do the probability of A plus the probability of B minus the intersection at least one time. See, notice up here there is no intersection, so we're basically subtracting 0. All right. Now, on the next one, when things are independent, you can just, if you want to multiply the probability of A times the probability of B, all right, on this one. And then on the next one, if they're not independent, it's the probability of, there we go again. It's the probability of A given, or times the probability of B given we've done A. So basically what that ends up doing is probability of B because probability of A cancels out. Now, number 5. A calculator, so basically this is, you have numbers 1 through 15. I want an odd number. There are 8 odds, so that's 8 out of 15. So whatever decimal that is. Something that will never occur has a probability of 0. Something that will always occur is a probability of 1. On this one, on number C, it says, what is A complement? Well, you know that A complement plus, A plus A complement has to add up to 1. Well, I already know the probability of A is 0.59. So if I subtract 0.59 from both sides, okay, I'm left with 0.41 as my A complement. On number 7, it gives you this information. You just got to fill in the rest of the two-way table. So this is going to be 25 and this is going to be 25. This ends up being 50 and 50. So that is 100. Both this adds up to 100, that adds to 100. So we're good to go. Now we're going to go answer these questions. I want the probability of getting a male or a Democrat. So basically we have to go through the intersection. So what I'm doing is probability of male happens to be right here, and then Democrat happens to be here, but we're only going to count this 25 one time. So what we're going to end up doing is we're going to do 35 plus 25 plus 25 over the total of 100. So that's 85 out of 100, which is 0.85. Oh, sorry, that's this one right here. Okay? Now, on this next one, if one person from this group is randomly selected, find the probability of getting a male Democrat. Well, there happen to be 25 male Democrats, so it's going to be 25 out of 100, which is simply 0.25. On number D, we want to know what's the probability of getting a Republican given that they are female. Well, when you have a given problem, what you do is on top here, you have to do the intersection. So that's this part right here. The intersection divided by the probability of what is given. So that ends up being 15, there we go, 15 out of 50, which happens to be 30 out of 100, which is 0.3, okay? Now, on number 8, we want to know the probability of that all 3 are women. Well, if there's 15 people, the probability, and there's 7 women to start off with, the first woman has a probability of 7 out of 15. The second woman, if we take that person out, now we only have 6 women left, and we only have 14 people left. And if I keep going, the third person, there's only 5 women left, but there's only 13 people total. So when you multiply all of those together, you end up with 0.07 6, 9, and that goes right there. Now, on number 9, we're going to look at the probability of, it says, the probability that they're all the same sex. Well, in that case, we want a boy, 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 and a girl, 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 girl. Well, the probability of this one is 0.5 to the 4th power, and that's what I've done right here. Same thing with the girl, 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 0.5 to the 4th power. When you put that in the calculator, you end up getting 0.125. On the next one, we want the probability of a day, that is 1 out of 7, times the probability of a month, that is 1 out of 12. And the reason I'm multiplying, again, they're independent events. So they don't rely on each other. So if they're independent, you can just multiply them, which is 1 out of 84, which is 0.0119. All right, on number 11, notice, excuse me, we have the 60% cure rate. That means cured is 0.6. That means not cured is 0.4. So I want 6 people who are cured. So they're independent of each other. So I basically multiply them all together, or I can do 0.6 to the 6th power, which is 0.0467. Same thing with no one cured. If I have all 6 people, the probability that the first one is not cured is 0.4. And the second one is 0.4, and so on and so forth. So I end up getting 0.4 to the 6th power, which is 0.00410. On number 12, you have 12 total batteries. And in the first one, we take a battery out, and then we put the battery back in. That leaves me 3 out of 12 for the first time. If I do another battery, I still have 12 batteries in there, and I still have 3 of them which are defective. So you just multiply those 2 events, and you get 9 out of 144, which is 0.0625. On 12B, we're going to change it up a bit. On the first pool, there's 3 defective batteries out of 12. But when I leave that one out, that leaves 11 batteries in the bag and only 2 defective ones. So if I multiply that together, I get 6 out of 132, which is 0.0455. Number 13 and 14, I've kind of put over to the side. Notice 62% take both math and science. So notice that's the center right here. That's this right here. I know that math has to add up to 0.85. So this has to be 0.23 because both of those have to add up to 0.85. Now, it asks, what's the probability that the person takes science given that they are in a math class already? Well, remember, in given, you have to do the intersection of the 2, which is 0.62, so that's why I put that right there, over the denominator, which is what is given, the probability that it's math, which is 0.85, which is those 2 right there together. That gives you 0.729 for that probability. On number 14, it tells you that 85% take math, 72% take science. So when we break it down, these 2 add up to 85% for math. These 2 add up to 72% for science. And I found this one out by knowing that 0.10 plus 0.62 has to give me 0.72. All right? Now, with that being said, the answer to that question is find the probability that it's math or science. You simply just add these 3 together. So remember, you can only add this one once. So those 3 added together add up to 0.95. Number 15, 35 unfavorable reactions. So you have to go find the probability that it's unfavorable. Well, 35 out of 60 is 0.58. So now, if I want something that the probability of unfavorable and then the probability of unfavorable again, well, that's going to be 0.58 times 0.58, which is 0.3364. Now, on number 16, it gave you the information. You simply just had to go fill in the rest of it. So there are 4 here because 8 plus 4 is 12. That means this has to be 5. That means this is 11. This is 9. Adds up a total of 20. Well, what I did was notice that this is the intersection of male and Republican. All right, so that's that right there, 8. I know that 8 plus 4 add up to 12. That's that right there. And then 8 plus 3 add up to 11, which is that right there. Now, once I have filled in all of that, I've also found my probabilities for each one of those 4 sections. When you come down here, it says make a tree diagram starting with the gender. Well, there's males and not males. Well, there are 12 out of 20. Out of the 20, there are 12 males. And out of the 20, there are 8 females. Then the next choice is whether they're Republican or not Republican. Well, if they are male, there are 12 Republicans, okay? If they're male, that's this category right here, okay? There are 12 males, 8 of them are Republican. That's why I have 8 out of 12. And 4 are not. So simply, you basically just simply do this. You have to multiply going straight across to find the probability, given that they're male, that they're Republican, which is 0.4. And then you just once you have all your probabilities set forth, you just simply multiply them, okay? And when you get all your probabilities out here to the right, if you add them all up, they should add up to 1.